Welcome to online classes. I am Dr. Vasumathi, working as an associate professor in the Department of CSE in Vignan Nirula Engineering College, Palakkadu. I have explained what are the translators. Translators are nothing but the which translates one form of a language into the another form. Right? So those are the translators. So now for all the programming languages, we will write programs in instruction by instruction, right, like that. Okay, so these programs are going to be executed by the compilers. So compilers are nothing but the translators. So now today's in this session, let us just go through the what is the total concept, the principle of compiler is, what are the different phases of compiler is. Okay, right. So my dear students, the compiler phases are: compiler is a translator, translates source program into the target program. Right? Okay. Right. So while just translating from source program into the target program, many more smaller steps have been there. Okay. So these steps you can call it as a phases. Okay. So totally 7 are the phases in compiler design. Okay. So compiler consists of 7 phases totally. So these 7 phases are grouped into as 2 passes. The first pass is analysis pass and the second pass is synthesis pass. Okay. Right. Analysis pass consists of, you know very well, yes, these are the phases of a compiler. Okay, right. So these are the 7 phases of a compiler. The first 4 phases represents the analysis pass. Those are lexical analyzer, syntax analyzer, semantic analyzer, and intermediate code generation. These 4 phases. For these 4 phases, the input is source program and the output is intermediate code representation. So this is the first pass. First pass consists of 4 phases. And coming to the second pass is synthesis pass. Synthesis pass consists of 3 phases. These 3 phases are only 2 tasks. Those 2 tasks are nothing but one is code generation and another one is code optimization. Right. Okay. So this code optimization is internally divided into as 2 different types. Those are mission independent code optimization and mission dependent code optimization. Okay. So my dear students, what is the second pass? Right. The second pass is synthesis pass. The synthesis pass consists of 3 phases. The first phase is mission independent code optimization and the second phase is code generation. And after generating the code according to the mission, it just optimizes according to the mission. That is what? Mission dependent code optimization. Is it clear? So these are the 3 phases of the second pass. Totally compiler consists of 7 phases. So these 7 phases are, you can group into as 2 different passes: analysis pass, synthesis pass. Okay, right? So I'll explain this each and every phase, how this each and every phase is going to be performed with an example. Consider the example, that is position is equivalent to initial plus rate star 60. This is a C instruction. Okay, right. Let us consider this example. Dear students, consider one example. Position is equivalent to initial plus rate star 60 at the end semicolon. You know very well this is a C statement, right? Now we know very well the different phases of a compiler. Consider this statement and let me check how this statement is going to be processed in each and every phase. Okay, right. So consider position is equivalent to initial plus rate star 60, right? So what is the purpose of lexical analyzer? Lexical analyzer reads each and every character stream. So here, first of all, it takes the character that is P. Next, it considers the character O, right? Like that. It reads S, I, T, I, O, N, and immediately it founds that the next one is nothing but one equivalent to, that is an operator. So here that is a symbol. So here it stops up to N and it considers this as an identifier, right? So this is a token of which pattern? Identifier pattern, right? Yes. So it has identified one identifier, that is ID1. So this is a token. This is the representation of a token. Okay. So like that, it reads each and every character by character and it prepares the token streams like this. Okay. Right. So what is the next one? Yes, next one is a symbol. So this symbol is equivalent to, right? So here this is one another token, comma. The next token is, what is the next token? Yes, ID2 is the next token, right? And what is the next one? Yes, that is a symbol. So it treats this as only single token, right? And what is the next one? The next one is, this is ID2, ID1, ID2, and the rate is ID3. Yes, like this. It prepares each and every token. It identifies the character streams in different pattern like this. So different patterns are these: operators, constants, identifiers, right? So this is the role of lexical analyzer. Lexical analyzer, right? Okay, right. So the next, what is the next phase? The next phase is immediately syntax analyzer. Syntax analyzer is also known as a parser. Parser takes the input as token stream and produces the output as, what is that? Yes, exactly. That is a parse tree or syntax tree, right? Let us consider. In this example, position is one identifier which is identified by the lexical analyzer. That is nothing but ID1, ID2, ID3. Three identifiers here. Three identifiers and one constant, and addition and multiplication operations are going to be happen, and finally equivalent to, right? So these are the different tokens have been identified by this lexical analyzer. So that stream is going to be given as an input to the syntax analyzer, right? Syntax analyzer. Now consider that syntax analyzer. See here in this entire expression, what is the operation that is going to be happen first? Yes, so you know very well, that is a multiplication operation. Multiplication operation performs on 2. That is, one is 60 and another one is rate. So what is that rate? The rate is nothing but, here in this case, the lexical analyzer has represented this as ID3. ID3 is one left node for this multiplication operator, and what is the right node? Right node is 60 as a constant value, right? So first it performs the multiplication operation and the resultant is summed up with the ID2. What is ID2? Exactly, that is position, right? So that is initial, right? So that is ID2. Initial plus rate starts 60, right? The final summation resultant is assigned to, that is an assignment operator. Assigned to, that is nothing but the first one, that is ID1. Yes, like this. So here in this pattern, the tokens are passed as an input to the syntax analyzer. Syntax analyzer produces an hierarchical representation, the meaningful representation, and there it checks the grammar, right? Okay, right. So this is the purpose of syntax analyzer. So what is the main input for the syntax analyzer? Yes, token stream is the input. What is the output? Parse tree is the output. Okay. What is the input for the lexical analyzer? Right, that is the source instructions, source code instructions. What is output for the lexical analyzer? Yes, that is the token streams. So here in this example, with this example, I want to demonstrate this, how each and every phase process each and every instruction given to that. Okay. Okay. Third phase is semantic analyzer. Semantic analyzer checks for corrections if any. That is what type corrections, type cohesions. So this is meant for that purpose. Is there any logical meaning is missing? So it checks for the logical corrections. Okay. So here consider the semantic analyzer takes the input as parse tree and produces the output as modified parse tree. So whatever it may be, here checks for corrections. If there is no correction, then it passes that verified parse tree as it is. Otherwise, if is there any correction need to be found, then it performs that. Okay, right. See here in this, see that all these are the floating point operations. Rate is all the times floating point. So for rate is nothing but ID3. ID3 is floating point, whereas 60 is integer, right? So it converts integer into float. So it performs such a modification in that parse tree. So like that here. So what is the first operation? First operation is multiplication, that is going to be performed on ID3, right? ID3 and 60. 60 is the constant. Actually, this 60 is here. The semantic analyzer converts integer into float. So here one simple operation is going to be performed, that is int to float. Okay, int to float. So then this is 60.0, right? Here it performs this simple modification in this entire parse tree, and the rest of the parse tree is same as it is. Okay, right. See here, what is the next operation? Summation on ID2. ID2 is nothing but initial plus rate star 60. 60 is converted into float. This is the job of semantic analyzer. So here, what is the output of semantic analyzer? The semantic analyzer output is parse tree. What is the input of semantic analyzer? Parse tree. So you can consider it as modified parse tree. Okay. Okay. Right. Consider the fourth phase. This is the last phase in the first pass. What is the first pass? Analysis pass. It consists of 4 phases: lexical analyzer, syntax analyzer, semantic analyzer, and intermediate code generator. Right. Consider this phase. The input for this phase is parse tree. Okay. So this is generated by our semantic analyzer. Okay. Right. So this parse tree is going to be represented in terms of an intermediate representation. The intermediate representation is nothing but the output of intermediate code generator. As the name itself represents that this is a code generator. Okay, right. So let us consider. Here, what is the first one? The first one is you need to consider, it has to translate 60 integer value into the float, right? So int to float operation int to float of what is the value? The value is 60. So int to float of 60 is the first operation, and it stores in some temporary variables, right? So here it stores in some so-called, you can write it as temp1. Here this temp represents that temporary variable 1, right? It stores that into the temporary variable 1, and multiplication operation is going to be performed on ID3, right? So here the next one is ID3 star, what it is? Temp1. Temp1 is nothing but the floating point value of 60. 60.0 into ID3, that is rate star 60 this is. So rate star 60 is going to be stored in somewhere else, that is temporary 2. Okay, right. So this temporary variable 2 is going to be summed up with what? What is that? That is initial. Initial, what is the representation initial? What is the representation of initial? Our lexical analyzer has given. Yes, that is exactly ID1. ID2. ID2 is the initial. Okay, right? So this is totally, the resultant is stored in somewhere else, that is somewhere temporary place, that is temporary 3. Right? So this temporary 3 value is finally assigned into what? What is our position? That position is nothing but ID1. This is a token representation. Okay, right. So this is what? Nothing but the intermediate code generator. Okay, right. The next pass is, what is the next pass? The next pass is synthesis pass. In the synthesis pass, it consists of mainly 2 steps only. One is code optimization and another one is code generation. And this code optimization is internally divided into mission independent code optimization and later on mission dependent code optimization. Okay, right. So let us consider the code optimizer. In the previous step, just I have explained you how the code is going to be generated. So the same code you can convert in terms of these 2 statements only. You can optimize. So it optimizes, the code optimizer role is, it optimizes the unnecessary steps. The first step is temp1 is equivalent to int to float 60. Right? Okay, so the direct operation is going to be performed here and it multiplies that directly with ID3 and directly here it assigns into the temporary variable 1. Okay, now consider this. The summation operation directly this temporary variable 1 is going to be summed up with ID2 and this is what? Totally assigned into ID1. So here it reduces many more unnecessary assignments and unnecessary operations steps. Okay, this is the main job of code optimizer. Let us consider code generation. Code generation here, it generates the code further. Okay, so what is the first one? So for this, it has to use some registers. So here R1, R2, like this. Many more, totally 16 registers. That depends on the computer architecture, right? So here, let us, for our operation, 2 registers are enough. Here, first, it moves the ID3 into 1 register. So here, now here, the ID3 value is. Okay, so that is a move. And next, multiply. So, multiplication operation is going to be performed on this floating point type. See here, if you want to write the mnemonics for the floating point type, you can write the mnemonics with F. Here it represents the, F represents, it's a floating point operation. Multiplication for floating point operation. Like that, so you are all working for floating point operations only. So here you can give move F, add F, move F, like that. Okay, so if that is a notation for floating point mnemonics. Okay, right. Consider this. Here it performs a multiplication operation of constant value 60 with the R2 register. R2 register consists of what? ID3. ID3 means what? Rate. Rate star 60 is over. That is rate star 60 is over. Up to this. Okay, right. Next, move F. Move F. So here it performs a, it moves ID2 value into one another register. Now here our R1 register consists of ID2. Okay. So here with this R1 you are summing up this R1 value with the R2 value. That is what you are doing here. That is initial plus rate star 60 finally you are doing. Okay. Right. So this is what the main operation, that is add F. And next move. Yes. So finally R1 plus R2, the resultant is stored in this R1 and this R1 is finally moved into the D1, ID1. Okay. ID1 is finally the position variable. Okay, right. So you see here, move F means it moves ID3 into R2 register. Multiply F, it multiplies this and stores the resultant in R2. Move F, it moves the ID2 value into R1. Add F, it adds R2 with R1 and stores the final resultant in R1. Move F means that R1 value is totally moved to the ID1 finally, which is we want. Okay, yes, this is what completely the phases of compiler is. Okay, so this is the example, and here in this example we have considered the C statement. Okay, right. Okay, dear students, so this is what the way each and every phase performs its own process, right? So these phases are also programmed. So overall, in summary, I want to conclude that the compiler is a translator which translates the source program into the target program. Okay, right? So by executing each and every phase, by performing each and every phase, it just simply converts, translates all program instructions into simply the output. That is what which you will see in your monitor. Okay, right. So the next one, very important questions have been presented here. Please all the students go through with that, okay, carefully. And these are the questions which have been given in GATE exam also. And this concept is very important concept. Okay, that is what the phases of a compiler. This is what many more in previous papers also have been given this. Okay, right. My dear students, just go through this entire concept and do good and do well. Okay, thank you.